How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, you and I are going to walk through the initial stand-up of getting, let me scoot this down just real quick, of getting our entire layer 3 environment here at the HQ location stood up. Now, what I'm going to do is I'm going to go basically device by device, except for like this, the access layer switches. They're not going to get a loopback address. Anything that's going to be routing will. So, and I'll talk a little bit about why you would want to use a loopback versus why you would want to use a VLAN ID, things like that. So we'll talk about that here in just a minute, though. What I'm going to do is anything that's going to be doing any EIGRP routing is going to get a loopback, and the IP address, the X is going to be the device ID. So it'll be here on Nexus 50 be 10.0.0.51. What we're going to do is we're going to enable EIGRP on all the connected interfaces, the SVIs, and all that good stuff that goes along with it, and get that propagation working in order for you guys to see what that looks like. So that's essentially what we're going to go out and do, get it all operational. Yes, this is going to be similar to what I did over in the smaller AS to the right of where I'm at. However, this guy right here, except for the fact that I'm not going to be going through the level of detail and explaining the how-tos or the specifics about EIGRP, I'm more or less looking for, we're going to be covering, okay, what do you do in this particular situation? Looking at some additional capabilities that are available to us and stuff like that. So I'm going to scroll up to the top here, and we're going to start off at the top and work our way down. So I'm going to go ahead and I'm going to say switch 7. We're going to actually scroll down here. Actually, I guess we can work our way up too. So we're going to go ahead and type in here interface loopback 0. IP address here is going to be 10.0.0.7/32. And I'm going to type in router EIGRP1. And if I do show IP interface brief, I have a bunch of 10 net IP addresses. And all I'm going to do for EIGRP to make it very, very simple is type in network of 10.0.0.0, and that should be all I need to do. Then I'll do show run section EIGRP, and it's running 10 everywhere. Perfect. Then I'm going to do switch 8, do the exact same thing. So what I'm going to go, actually let me go back over here real quick. I'm going to type in router ID. The EIGRP router ID is going to be 10.0.0.7. I'm going to go to switch 8 and do the exact same thing. Go to global config, interface loopback 0. IP address here is going to be 10.0.0.8/32. Then it's going to be router EIGRP1, EIGRP router ID 10.0.0.8, and then network of 10. Now, what will end up happening is we're going to form adjacencies over the SVIs for VLAN 10 and VLAN 11. And I'm going to come back to this, why you won't want to do this. This is not exactly, this isn't a good idea. And I'll talk more about this later on once I get everything stood up. But it probably won't affect us initially, but for right now, I'm just going to go through and say, you're normally not going to want to do this. So, wrong one. So I'm going to go hit the enter key, and then I'm going to scroll back up, and I'm going to work my way through, let's do Nexus 50 and 51. So over here, I'm going to log into Nexus 50. We're going to interface loopback 0. IP address here is going to be 10.0.0.50/32, and then I'm going to turn EIGRP on. So feature EIGRP, and then we're going to type in router EIGRP, and then we're going to say 1, and then we're going to come underneath here, we're going to say the autonomous system number is going to be 1, and then we're going to say the router ID is going to be 10.0.0.50, and I'm going to go where I want to enable EIGRP is I have to go show IP interface brief, and I'm going to go to interface VLAN 20. I'm going to type in IP router EIGRP 1 and hit the enter key. And that's how you turn EIGRP on a Nexus switch. Same thing with OSPF, RIP, ISDIS. So I'm going to go to interface ETH1/5 and do the exact same thing. Now, the question that I get every once in a while is, do I enable EIGRP on the loopback interface? So, two ways to answer that question. What is the loopback address used for? Number one. If it's used for any type of management or monitoring, then yes. If it's not used for either management or monitoring, then why do you have it? Oh, I have hold on. Isn't it needed for the router ID? No, it is not. You don't need to have a loopback address for a router ID to work. A router ID is literally just a IPv4 dotted decimal address that it's in the format of an IPv4 dotted decimal address, but it doesn't actually have to be a routable IP. It's just something to identify the device inside of EIGRP updates. So for the sake of argument, I'm not going to enable it here. So what I'm going to do is I'm going to do a show IP EIGRP interfaces, and we can see I'm enabled on those two. So then I'm going to go over to 51, do the exact same thing. Admin and admin. So I'm going to go to here, and I'm going to type in feature. I'm not going to enable a loopback in this particular case just to prove my point. So I'm going to type in feature EIGRP, and then I'm going to go to router EIGRP1. I'm going to state here the router ID is going to be 10.0.0.51, right? And then I'm going to say that actually, did I enable logging on this guy? Router EIGRP1, log adjacency changes. Log adjacency changes. So show run all router EIGRP. Show run router EIGRP. Show run EIGRP. That's right. Show run EIGRP. Okay. So show run all pipe section EIGRP. Log adjacency changes. Let me just double check on this guy here. Show run all pipe section EIGRP. Yep, it's going to do it automatically, so I don't have to worry about it. So on 51, I'm going to go over here and I'm going to go to interface E1/5, IP router EIGRP 1, and then interface VLAN 20, same thing. Now we're going to form actually, you know what? I forgot. Let me logging console 7. And let me go, yeah, see, I forgot to turn on debug. So, logging console 7. So what I'm going to do, well, show IP EIGRP interfaces, and we're going to do show IP EIGRP neighbors, and I have an adjacency with 51. So now that I've got that turned on, I'm going to go ahead and just save the config real quick for that. Now that I've got those guys done, now I have the remaining routers. I've got 25, 57, 41. Some of these boxes are already got consoles open to them. Some of them don't. So I'm going to go ahead and open up 23. Why is 23 sitting over there? I don't know. Sometimes these guys get out of order and I don't even realize it until I go look. And 27 needs to be way over here. So does 26. Don't ask me why they're all the way over there. So that's good. So now what I'm going to do is I'm going to go ahead and open up 25 because that one isn't already open. And then I'll move that over. 25. Then I'm going to do 57. 57 isn't already open. 57 is there. Move 57 over. 41. 41 is now open. Move it over to where it's got to go. How did 29? It blows my mind sometimes how stuff gets out of order. Anyway, 49 is already there. Then I'm going to go ahead and open up switch 13. Move him over. I know you guys can't see this. Switch 14. Move switch 14 over. And then 33 and 34 are good. Now I just need to open up 58 and 59. So 58. Okay, now he's in place, and then 59 respectively. Okay, perfect. So I'm going to bring this back over. So now I have the routers that I want enabled. So what I'm going to go do is, working from left to right, I'm going to grab 25. 25 is not even configured, right? If I do a show IP interface brief, nothing's there. So 57 I don't believe is either. Yeah, so we're going to have to configure a couple devices. So what I'm going to do is I'm actually going to pause while I go through and at least configure the initial interfaces with their IP addressing, and I will I'll bring you guys back in once I have the IP addressing done, and go from there. So it'll be for you it'll be a split second. For me it'll be probably 10 minutes. So as I'm going through the initial deployment, I've gotten a couple devices done, and then I came across XR41, which I never actually bootstrapped initially, so the system has just been sitting idly along. So what we're going to need to do is enter a root username. So I'm going to go ahead and set Rob, and then enter the secret, which is going to be Cisco, 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 and that's really it. There's not a whole lot to it. And then you just type in Rob and then Cisco, and away you go. So I'm going to go to global config. I'll set the host name to be XR41. And remember that in order to do a XR deployment, you have to go through and commit all your configurations. So I'm going to knock this config out real quick, and then I'll bring you guys back in. So I've going through and configuring the remaining parts of the switches, and I ran across this issue right here where you've got a full duplex issue. So in order to fix this, you've got to go to global config, and then on interface gig0/1 type in switch port no negotiate, and then no switch port, and then duplex full. Auto negotiated duplex. Okay, so that's how you fix that. Now that I have all of the IP addressing done, we're going to go ahead and move forward with all of our EIGRP config. So we're going to start down here at the bottom. We're going to continue from 50 and 51, I should say. So we're going to go to switch 7 and show run pipe section EIGRP, and we've already got that one enabled, which is good. And we've got this one here as well, just double checking show run pipe section EIGRP, that one as well. So I'm going to go to the core here, R25, and we're going to go ahead and go do show run pipe section EIGRP. EIGRP is not enabled yet. So we'll do router EIGRP1. And then for simplicity, I'm just going to use the network statement of, I'll set the EIGRP router ID to be 10.0.0.25 and the network statement to be 10.0.0.0. So we should form EIGRP adjacencies pretty quick with 51. And then I'm going to jump over to 41. I'll do this kind of in numerical order. Let's go to 41. Log in as Rob and Cisco. We'll go router EIGRP1. We're going to specify the address family IPv4 unicast, and then we're going to say the interface, the autonomous system 1, and then we're going to go, was that available before? It was. Actually, I can't do that. You can pull that out. We're going to go interface gig 00000, gig 1, gig 2, and gig 3, and then interface loopback 0, And then we're going to also say the exit out one more time. We're going to do the address family IPv4. Router ID is going to be 10.0.0.41. And we're going to go ahead and actually let me also add in log neighbor changes. And we're going to go ahead and commit that. Now, I don't know if you guys can hear this or not, but every once in a while there will be a ding, and it was really starting to irritate me because it was trying to do config changes and it was kept on dinging while I was trying to talk. It's actually a secure CRT audio bell. So we're going to go here, go to options, session options, and then underneath terminal, we're going to uncheck the audio bell. I didn't realize this was even a thing, so that should turn that off. So I'm going to go over to 49 now, work my way up. Log in as admin and admin. And we're going to go to global config, feature, EIGRP. And then we're going to go to router EIGRP1. We're going to set the router ID to be 10.0.0.49. And then log adjacency changes. And then I'm going to go to interface ETH 1/1 through 5. I'm going to say IP router EIGRP1. And so we should start to form EIGRP adjacencies with other equipment, which we are. I'm going to jump to 57 after this. I'm going to do router EIGRP1. And we're going to specify router ID. And again, here, let's go turn the option session and then audio bell. EIGRP router ID is going to be 10.0.0.57 and then network of 10.0.0.0. You could technically do all zeros as well, but that would enable EIGRP on every interface no matter the IP address. Okay, so that's going to bring that online. So 25 and 49 are both paired now. So then we're going to go over to 13 and do the exact same thing. It's going to be router EIGRP1. EIGRP router ID is going to be 10.0.0.13, network of 10. And then we're going to go to 14. Router EIGRP1, EIGRP router ID 10.0.0.14, network of 10 splat. And then we're going to go to 33. Router EIGRP1 and do show IP interface brief. I'm going to enable this on the 10 interfaces, the 10 dot interfaces like I've been. So EIGRP router ID is 10.0.0.33 and the network of 10.0.0.0. So I'm just going to go ahead and I'm going to do show run pipe section EIGRP, and I'm going to grab this config here, pull up Notepad real quick, and we're going to just adjust this. So we'll make this 34. And one thing I'm going to do real quick is when we get down to 58 and 59, I'm going to make a slight adjustment, because when I go to do the MPLS VPN deployment, which is hanging out over here in the lower right hand corner of your screen, I don't want to enable EIGRP on these interfaces. So we'll make a quick adjustment there. So I'm going to go ahead and do that. Then I'm going to go to 34, paste that config in. Then we're going to jump over to 58 and 59. And I'm going to go ahead and for this guy here, I'm going to do 10.14 because they both connect to 14. 0.0.255.255. And I'm going to make this a 58. Copy that over here to 58. Paste that in, and then 59. And 59. Okay. So now we should have EIGRP adjacency with all that stuff. Okay, so I want to make mention that the configuration that I'm doing, I did. So, side note, I was scrolling through LinkedIn earlier this evening, and there was a comment made. Somebody shared my YouTube channel to somebody on LinkedIn because they were talking about MPLS VPNs, and I've covered a lot of MPLS VPNs on my channel. So the person that commented said that I'm kind of quick, and so I had to I'm gonna have to apologize to some of y'all that are watching this content. And I'm moving very, very quickly. The one thing that I want everybody to keep in the back of their mind is that what I'm showing you is just ways to just be faster in general. Now, I know if you're like getting to your CCNA and you can't keep up with the configuration, that's okay. That's why the videos can be watched over and over and over again. So that's one thing that I want you guys to keep in the back of your mind is I've been doing this for a very, very long time, and I've done it so many times. A lot of it's just second nature. So the way that I equate it to folks is I have my black belt in networking, and I just know a ton of different techniques. So a lot of the things that I do that are what I would consider very CCNA level implementations, they're quick just because of the fact that I already know what I'm going to do. So it's no different than you watching a couple of black belts, or watching a black belt versus a white belt. It's very, very clear that the black belt knows what they're doing. So hopefully by the time you guys are done with this entire series, you are very, very strong in networking because you're going to be going through a lot of the technologies that's on the CCIE blueprint. You're walking through a lot of the technologies and implementation methodologies with someone that's been through the fire. I've prepped for, taken the CCIE lab, and I've successfully passed it. So just be knowledgeable that I am not doing anything. There's no showing off here. This is me just walking you through how these things would work. So if you guys have any questions, comments, concerns, stuff like that, drop it in the comment section. But just wanted to point that out, that I'm not trying to go fast on purpose to try to make myself look cool. It's, just the nature of the beast for me. So with that being said, we have all of our routers enabled for EIGRP that are visible, and everything looks pretty good. So what I'm going to go do now is I'm going to jump out of global config. We're on 59, so we're going to have a full view of the network. I'm going to go ahead and get out of the way, and I'm going to do a show IP route. So we should have a bunch of EIGRP routes. So there's no good place for me to go full screen with this. So let me go ahead and drag this down. We have a lot of EIGRP routes. We have a lot of our router IDs that are defined, all that good stuff that goes along with that. So a lot of internal routing, right? We have a lot of the via next hop. So we have a lot of connectivity in play for what it is we're trying to get done, right? And this is what a real world EIGRP deployment might look like. Now, the one that I want to talk to you guys about isn't so necessarily the end connectivity, because this is actually the easy part, right? Looking at the routing table and identifying the administrative distance for EIGRP, and then seeing the composite metric for a particular prefix, the 131.584, so on and so forth. That's the easy part. Where we go to optimize and make EIGRP better is when we're looking at stuff like switch 7 and switch 8. So one of the first topics that I want to talk to you guys about, and I don't even know if it's on the pull up the CCA blueprint real quick for EIGRP. Yeah, it doesn't even have it here. I'm going to EIGRP stub. One of the basic EIGRP what's the word I'm looking for? Optimizations that you can do out of the gate, which to me, I'd say is something that a CCNA working towards their CCNP would want to know. Somebody that's working towards their CCNP should definitely know. This is definitely not a CCA hack or trick or anything like that. Is the concept of a stub router. I want to talk to you guys a little bit about what that means, because it's going to be important, especially if you get into a large scale deployment where you've got a hierarchy like we do here. We've got this environment built out where we've got our core, right? We have a Nexus distribution block, we have a Catalyst distribution block, and we have our internet edge, and we have our WAN edge. Well, in this particular case here, on our campus edge, right, the connection that goes to the core, the distribution layer, one thing we don't want to have happen is unnecessary EIGRP adjacencies for the sake of EIGRP adjacencies. Now, I say that the way that I do. Ironically, there was a customer that I worked with about 4 or 5 months ago where my job, I came in to do an assessment, so I had about 100 hours or so worth of time to sink into this customer. So I completely mapped out their network. I took an inventory of what they had, and I went through and made sure that I understood all the things that were going on. Now, when I did that, I was able to go through and fully map out their environment, and then I was able to map out layer 2 and layer 3 on top of that. So I built what you guys see here, right? I built this out so I knew who was connected to who and how, right? So what equipment was there, what interfaces were being used to connect to everything, all that good stuff that goes along with it. And then I went ahead and I took it to the next stage. And I was like, okay, what are trunk links? Where do we have chassis aggregation? Where's routing? So I mapped all of that out as well. And by doing that, I was able to map layers 1, 2, and 3 together at the exact same time on the same topology. So it made it very, very easy to determine how the network was laid out. Now, one thing that I noticed was I remember this one pair of routers had 6 OSPF adjacencies between itself. So what they were basically doing was in between switch 7 and switch 8, they basically had 6 individual OSPF adjacencies going over that. And they had another number of OSPF adjacencies over the LAN interfaces. So the drawback to that was there was nothing southbound of these devices. These were sitting at the edge, right? They had, distribution layer, and then they had a bunch of users sitting southbound. So they had no reason to be running OSPF on these interfaces right here facing downstream to the access layer switches. So that's what we're going to be focusing on right now, is how do we handle that, right? It's a common thing that a lot of engineers, especially those that have started down the networking, they deal with networking, they go down that road, but they only go as far as they need to in order to get the job done. So, and they're not to say there's anything wrong with that, but the approach, in my opinion, a lot of people they do just this. They do a show run section EIGRP. They learn what the minimum is needed, and they apply that. There's no optimization done for any routing protocol, whether it's OSPF, EIGRP, BGP, what have you. And I mean, that might be the case. Their job, their center of their world may not be networking. And that's okay in some cases, but you and I are taking that a step beyond, right? You're here to understand how to optimize EIGRP. So even though it's not a very, very obvious optimization, it's something that we definitely need to talk about. So what I'm going to dig into here is going to be, how do we prevent switch 7 and switch 8, from allowing unauthorized, non-authenticated EIGRP adjacencies, and then how do we prevent the rest of the network from sending queries throughout the rest of the network to a part of the network where we can guarantee there's nothing downstream of that. So let me cover the first one. If we look at switch 7 and switch 8, and I'll go ahead and get out of the way, if I do a show IP EIGRP interfaces, you'll notice that on my interfaces that in the first column here we have peers. On VLAN 10, I have 1 peer, and on VLAN 11, I have 1 peer. Now, is that a good thing or a bad thing? Well, in my opinion, it's a bad thing. So, why would you want to have EIGRP adjacencies on your SVIs? Well, what's actually happening in order for this to work is this. We are having the connections. So there's a good chance that the hellos are going back and forth this way. So what I could do to see if that's actually the case is I can shut down the port channel set up between switch 7 and switch 8 and see if the adjacencies go down. Now, what you don't want to do And in the case if that is the case, let's go ahead and just verify this. So let's assume that we don't know. And at this moment, I don't know. So we're going to assume it's possible that the hellos are going out this way and going out this way to between switch 7 and switch 8. Now if it's going out this way, that's what we don't want to have. If it's going out this way, that's acceptable because there's routing back and forth between the switches. So if something happens on the upstream connection on, say, gig 1.1 on switch 8, we want switch 8 to be able to take traffic in from 9, 10, and 11 and then forward that across the port channel outbound on switch 7. That's an acceptable reconvergence scenario. However, what we don't want to have happen is this link go down and then traffic, for whatever reason, ends up coming down this way and then going back up that way. That is not a reconvergence event that we want to have. So what I'm going to go do is we're going to look at this by looking at switch 7. I'm going to go ahead and get out of the way. We're going to do a show interface trunk, and we have port channel 1 there. And what I'm going to go do is I'm going to shut down interface port channel 1. Now there are more effective ways of doing this, I will be honest with you. You could go in here and look at the interface level, like you could go to interface gig 0/0 and look at the amount of traffic going back and forth. And we see some traffic, right? 377, 471, 146. You know, we see that going back and forth. So the numbers are increasing, right? The input packets. Now, if I was to look at gig 2 and look at 160.117, 160.117, 160.117, looks pretty consistent, right? Doesn't look like there's a whole lot going on. So to see whether or not our EIGRP adjacencies are going through the LAN side or if they're going through the port channel, interface port channel 1, I'm just going to shut it down. Now by shutting down the port channel, that should shut down the member interfaces, and if my EIGRP adjacencies go down within a short period of time, about 15 or so seconds, then what will end up happening is, and there they go, EIGRP failed. Now, is this something I would do in production? No, I would not do this in production. But what it does prove is that EIGRP, the hellos between these two devices, are going back and forth across the port channel. Is that acceptable? Yeah, it's acceptable. Now, what we don't want to end up at, and see here, so this is where we are seeing 10 and 11 come back online. Now, the question is, where's it coming back online from? Well, if I do show interface gig 0/2, now we're seeing 162.88, 16300, 163.07, 317. So what you're seeing now is because the port channel is down, now in order for the EIGRP adjacencies to come online and for them to work and for HSRP to do its job, the traffic is going down from switch 7 gig 0/2 to switch 9, and it's going over 9, 10, and 11, honestly. So if I was to look at gig 3, we should see traffic on that one, and we should see stuff on gig 1/0 as well. It might not be incrementing quite as quickly as it is on gig 2. It looks like gig 2 is the interface that it's actually leveraging. But as you can see, my point, we see that information going back and forth. So right now, gig 2 is the interface that's being used to forward all of the the EIGRP and the HSRP hellos between 7 and 8. Now the reality of it is this. You normally would never want to configure a pair of distribution layer switches to form EIGRP adjacencies with each other over the LAN facing interfaces. Where you do want to form an EIGRP adjacency is going to be on the switch going northbound, so gig 1.1 up to XR41 and to Nexus 49. That's an acceptable EIGRP adjacency. Now what will end up happening is on switch 7 and switch 8, what we can do is I'm going to go ahead and no shut the port channel, interface port channel 1. No, okay, there it goes. So it's no shutting it, it's going to come online, and what will end up happening is the hello should start to go back over, say, gig 0/1. So if I do the hold time is down, and it'll flip back over, and it will start using the point-to-point again. This port channel here, more than likely momentarily. Now, what you normally would do with EIGRP on a distribution layer switch is you would go to the protocol level, and there we have EIGRP coming back online. What you normally would do is you'd go to router EIGRP1 and do show run section EIGRP, and what you would do is you would say passive interface VLAN 10 and VLAN 11. Now what that's going to do is it's going to still allow EIGRP to advertise VLAN 10 and VLAN 11 into EIGRP. So it's going to allow the rest of the network to learn that. So if we were to go to XR41, for example, and let's log into him and do a show IP route EIGRP, right, we're still going to see 10.1.10 and 10.1.11, right? We want to see that. Now if I go to switch 7 and switch 8 and I type in passive interface, I could say default, which is right here, which is express routing updates on all interfaces. I see a lot of customers using that by default or out of the gate. They use passive interface default. It turns off routing on every interface, and they selectively unpassive interface SPIs as they need to. So instead of doing that, I'm just going to say passive interface VLAN 10 and VLAN 11. That's going to take the adjacency down between 7 and 8 for VLAN 10 and 11. And then I go over to switch 8 and do the exact same thing there. I'm going to type in router EIGRP1 and then passive interface VLAN 10 and VLAN 11. Now if I go back to XR41 and I hit the up arrow, I didn't lose the subnets. Subnets are still there. And why are they still there? Because if I show IP EIGRP topology, show EIGRP topology, we're still going to see those subnets getting advertised from the downstream neighbor. So in this case here, 10 and 11, we're still seeing them on gig 0/2, which is right here. So that's the first thing that you would want to do. You'd want to go in and turn passive interface on for any interface that you don't want to form a dynamic routing peering on. So this might be, again, it's any interface that you like. If your network statement is too broad and you don't want to form an adjacency for that particular protocol on a particular interface, it's set that interface as passive. So it will not send nor receive any routing protocol hellos for that protocol, and it'll never form an adjacency with another device. So passive interface is a big deal. Something that I definitely want you guys to be aware of as you move forward. Now the other thing that I want to talk about is the concept of query domains. And so when we bring up the CCIE blueprint, they refer to it as query boundaries. Now what this means is, go ahead and minimize that again. If something happens in the network, let's say this interface goes down. So let me go over here to, let me go to 57. I'm not sure exactly the best place to do this debug, but let me do a debug EIGRP address family IPv4 unicast. Actually, no, debug IP EIGRP 1. That's not what I'm looking for. Debug EIGRP packets, and I'm looking for query. Query. I'm looking for a reply. Stuff like that. And then you have the stuck and active query, and you have the stuck and active. Let's see, query hello packets, and I'll debug EIGRP packets ACK. So what I'm going to do is I'm going to shut down on XR41. I'm going to shut down the gig02 interface. So I'm going to go to here. I'm going to go to interface gig000002, and I'm going to say shut down. And if I jump over to 57, as soon as that triggers, oh, I got to commit it. Forgot about that. 57 immediately gets a bunch of messages regarding that particular interface. So he's sending out, sending ACK, received ACK, all that good stuff. So what it's basically, it's not very clear as to what's happening. EIGRP debugs are a little quirky to read. But essentially what was happening was 57 got a bunch of queries. Hey, do you know about this link going down? And if you do, how would you route around it? So in order to go, say 57 again, we're going to go show IP route for 10.1.10.0. We're going to be learning that via, in this case here, gig 2, because XR41 is down. If I go back to XR41, and I do a show IP route EIGRP 10.1.10.10, it's been up for 23 minutes. So we're obviously taking the path via 49 to go there. That's very evident for that. So I'm going to go back to 41. I'm going to say no shut and commit. But 57 is going to get a bunch of updates to say, okay, hey, this is what's going on, and we're in good shape. So everybody's responding to it, saying everything's good to go. So we're getting a bunch of acknowledgements. And if I do a show IP route EIGRP, you'll notice that for 10 and 11, we do get a new update because the route was repropagated. But we know that it's reachable by 49. So we know we're in a good spot there. So that is, so in order to fix that, what I'm going to go do is, I'm not exactly sure if that's a great example of what I'm trying to do, but what I want to do is I want to tell switch 7 and switch 8 that these guys are stub routers. So you might ask, well, what's a stub router? A stub router is any router that is considered to be at the edge of your EIGRP domain, your edge of your autonomous system. So essentially what that means is there's no devices southbound logically of me, so therefore if something's going on, don't send me a query asking me if you know about an alternative path. So what will end up happening is if we go over to 41 again, and I do a jump out of global config, and I do a show EIGRP interfaces gig 000002 detail, what I'm looking for right here is there will be a message that pops up that says, okay, query, neighbor is a query, I believe is what it's going to stand for or say. So in switch 7, I'm going to come in here and type in EIGRP stub, and by default it's going to do connected and summary. So I'm going to type in EIGRP stub, and then 57 is going to get a whole bunch of updates basically saying don't send me a query. And if I go to 41, you'll see that the adjacency goes down, goodbye received, and if I do the detail again, let's see, interfaces, maybe it's EIGRP neighbors, gig 0002 detail right here. So it's not the interface, it's the neighbor. Stub peering advertising. So if I go over here to Nexus 49, I jump out of global config and I type in show IP EIGRP neighbors the detail, or Ethernet 1/3 is a detail Ethernet 1/3. And if I go down to switch 8 and I type in EIGRP stub, 49 now it's gonna take down the adjacency. It's gonna bring it back up, but now I'm gonna have stub peer advertising connected directory, connected or direct summary, and then these are the routes. So what exactly does it mean with all these options here? When you do an EIGRP stub, you can do advertise connected routes, so things that are directly attached to me, do advertise summary routes, because you might have, instead of advertising, for example, 30/24s, you might be able to concatenate that down to a single, say, /21, for example, or /19, something like that, something that's a much smaller range. So that's going to be something you're going to want to do. Then you have a leak map where you can leak specific prefixes outbound, receive only, so only receive updates. You're not going to send any. If you have a static route pointing to something else, it'll advertise a static route for you. Redistributed would obviously be if you're redistributing from another protocol into EIGRP, you would allow those routes to be propagated as well. Stuff like that. So one of the things that I can do is let's take a look at it from a summary perspective. Let's say I've got 10 and 11. So what we're going to do is we're going to do a little bit of exercising here with binary. We're going to find what they call the most bits in common in the subnet mask to see what actual summary route can I generate from 7 and 8 so that 41 and 49 learn it, propagate it to the rest of the network as a summary route, and encompass 10 and 11. So I'm going to come down here and let's do some math. So the first thing we're going to do, again, is going to be the 128, 64, 32, 16, 8, 4, 2, 1. So what we want to do is we want to take the 10 and 11 is what we know is going to be the case. So we'll just start there. So we know a 10 is going to be a 1 and a 2, a 0, 0 here. And an 11 is going to be 8, 2, and 1. So what are the most bits in common? It's going to be right there, right? Because it's right there. We're zeros everywhere else. So what we need to do is we need to figure out what subnet range is that. So we have a couple of different options for this. We know 10 and 11 are the subnets in place. For whatever reason, that is what the brainiacs, me being the brainiac, decided to use for his addressing scheme. So what we're going to do is we need to figure out, based off of this, off the 8, we know 8 is the range. So that's the first thing we got to keep in the back of our mind. So if we know it's 0, then the next one's going to be 8, then it's 16, which means we're going to be somewhere in this range right here. Can we tighten it up? We technically could and make it down to 2. But the reality of it is we are dealing with which is essentially a /23, right? Because a /23 equals to 2 /24s, right? That's a /23. So we theoretically could do this where it also maps here, right? So what we really want to do is we want to figure out how do we take these 2 /24s and concatenate that down. So we'll do it both. We'll take a look at it from both ways. We'll test both ways to see which one works better. So what I'm going to do is I'm going to take the 8 and the 0 and the 16. So which means my subnet mask is going to be what? I'm in the 3rd octet now. So that's going to be this one right here. So we have 8 and 16. So we know we're going to go 1, 2, 3, 4. So it's going to be 128 and 64 is what? 192 plus the 32 is going to be what? 224 plus the 16 is going to be what? Be a 240. So it's a 248 is my mask. But the thing is, we're going to start off with a 10.1 dot what? We have to start off with an 8 range, right? 8.0 slash, so it's going to be 1, 2, 3, so 24, this will be a 23, be 22, 21. Yeah, right? So 17, 18, 19, 20, 21. Yeah, I don't know why I was second guessing myself. So that's going to be what that is going to be. It's going to be a /21. But a /21 is going to encompass a lot of subnets, right? So obviously this isn't the right way to go, right? Because this is way too many. Because a /21 is going to be 1, 2, 3. So it's going to be 7. It's going to be a lot of subnets. So remember, /22 is what? That's going to be 4 /24s. And then a /21 is going to be equal to what? 8 /24s. Now we've got 2 /24s here. Obviously, this is not the direction we want to go. So what we want to do instead is circle more on this because it's 2 subnets. It makes way more sense. Now, but the only thing we have to do figure out now is going to be what's the range for that. So it's going to be 2. So I'm going to go 0, 2, 4, 6, 8, 10. Would that work? Well, let's do the math on that. 0 through 1, 2 through 3, 4 through 5, 6 through 7, 8 through 9, 10 through 11. That might actually work. So what I'll do is this is going to be a 22, this will be a 23. So again, going back to what I talked about originally, this is really what we want right here, right? So what's the most bits in common? So our subnet mask won't be a 248, it'll be what? 248 is 21, so it'll be, so 128 and 64 is 192, 192 and 32 is 224, 224 and 16 is 240, 240 and 8, 248. So it's going to be a 240, 252, a 250, 253. Correct. So that's going to be a 254. So let's go ahead and test that. Let's go back up here. Hopefully my math is correct. Pull up our, there we go. So I'm going to say summary is already there. So what I'm going to do is on the connected interface on gig 11 on both devices, I'm going to go, let's switch 7. I'm going to go up here. I'm going to type in interface gig 1/1. And I'm going to type in IP EIGRP IP summary address for EIGRP 1. And what's the address going to be? It's going to be 10.1.10.0/23. And then I'm going to hit the enter key. Now I'm going to go up to 41. I'm going to do a show IP route EIGRP. Now, does that... Oh, well, let's look at that. That looks a little cleaner, right? So we're going to look up at this a little bit better. So now we get the /23, right, it's coming through. Let's do that on switch 8 as well. We'll grab this config right here, because once we have it figured out, it makes more sense to allow this. Now on switch 8, we're going to go to interface gig 1/1, and I'm going to type in that. So it's going to resynchronize the neighbor to update what happened. We're looking at N49, show IP route EIGRP, and we do have the summary right there. Now if I go back to XR41, you'll notice that after a little while, the longer /24s go away and it's replaced with the shorter match /23. And N49 is doing it right away. We can see that right here. 10.1.10.10/23, EIGRP 1, everybody's happy. And that, ladies and gentlemen, is how you do your what's the word I'm looking for? Passive interfaces. I can't believe I couldn't think of that word. That's how you do your passive interfaces in order to prevent your SPIs from forming EIGRP adjacencies with each other over the connected LAN. And there's a number of reasons why you wouldn't want to do that. One of which is you wouldn't want to accidentally have to route through the access switches in order to get to the other distribution switches. That's not something you ever want to do. So that's one of the reasons why you do that, which is why you don't wire everything directly to each other either from a layer 2 perspective. is you build things in triangles so that you always have a determined path of where you're going to go. The next thing is going to be stub routing. You want to turn on, there's nothing downstream of switch 7 and switch 8, so there's no reason why XR41 or N49 should ever ask switch 7 and switch 8, hey man, do you have any, do you know where this particular subnet is? It's like you walk, if it's like, we call it a drive-by in IT where you're, you're at the office, and you know your coworkers in another cube. You just walk up and you knock on their door like, hey man, I got a question for you. And they're like, what's up? Or they might be like, hey, I'm in the middle of something right now. Or you read the room, right? So you walk up like, hey, I got a question for you. And then you state your question, right? So in situations like this, the stub is essentially preventing from people coming you asking the proverbial stupid question. Like if you know that person doesn't know the answer to the question, why would you ask them anyway? That's right, Captain Obvious, right? All right, so we have /23 rolled out. So the key thing here is, even though from a binary perspective, 10 and 11, the actual decimal number, or the actual numeric value, 10 and 11, are made up with 8 and 2, and then 8, 2, and 1 in order to make 10 and 11. But the reality of it is, there's only 2 bits in common that make it up, and it doesn't make sense to make your summary super, super, super wide. And here, another reason why you don't want to do that is because if you accidentally summarize too wide, so you encompass too many subnets, you could be advertising way more than what is actually reachable by the network. What I mean by that is, if I had done, say, so right now we're doing a /23 on both. So /23 is getting advertised this way, right? And it makes sense. We're doing 10 and 11. That's the address size that we need to be propagating. Now, what happens, because that's encompassing 10 and 11 respectively. But what happens if I would have gone with the /21? What would have happened then? Well, I would have been advertising a whole lot more subnets. I would have been advertising, because 10 and 11 fall between 8 and 16, I would have been advertising 8, 9, 10, 11, 12, 13, 14, 15. I would have been advertising 8 individual /24s, right? This all encompasses 8 /24s. So we would have been advertising 8 /24s, but only 2 of them would have been reachable. Now, why is that a bad thing? Yes, it is. Why is it a bad thing? Well, because there is nothing for these guys right here, and for these guys right here, there are no subnets on that box. So essentially, but they could be somewhere else. It's very possible for an addressing scheme to get skewed over time, and for those subnets to be in place in a different part of the network. And what you wouldn't want to have happen, let's say for example that's not the case. You've done a really good job of doing your address scheming so that you don't have weird addressing schemes anywhere in your network. Everything is uniform across the board. Very rare, but let's say you're the unicorn network and that's the way it is. Well, in that case then no harm, no foul. But you would still be advertising 6 /24s that aren't even configured. And by doing a /21 northbound, you are signifying that you have 8 /24s that are reachable down here. The reality of it is that you don't. If you don't have something in your advertising that you do, it's called black holing. Because if I was to send traffic down this way, it's going to get to here and it's going to die. Like nothing's ever going to respond to it because there is nothing to respond to. So that is why we do that. Now, going back to the other example where that subnet is being used elsewhere, but you didn't do a very good job of doing your summarization and you summarized way too wide. So you're accidentally encompassing subnets that exist elsewhere. What's going to end up happening then? Well, as long as that subnet is advertised from its location, wherever it might be, as the longer match, so the /24 sits over here on and Nexus 50, for example. Well, if you advertise a /21 as a summary, but a /24 is reachable somewhere else, which way do you think is going to win? Go ahead. Correct. The /24 is going to win. Why? Longest match. I know I can't write. There's supposed to be an S right there. So longest match is always going to win. So you're always going to route to the longest match. So what happens if you were to take this a step further with your summary and maybe you were to do a leak map? What's a leak map? A leak map is going to allow more specific prefixes like a /24, /27, something like that, to get leaked in addition to your /21 or your /23. What'll end up happening then is you will have competing longest match routes. So what'll end up happening is if you accidentally leak a prefix that A does not exist, but you incorporate it as a route from a leak map during summarization, what ends up happening then is the longer match that doesn't really exist over here gets advertised, and the traffic that's trying to go over to this guy never gets there because the routing has it come over here. That's what ends up happening. So that's why it's very, very important, well, no matter what you're doing, that when you're doing summarization, that you're cautious on how you do it. You don't want to be the guy that goes out and just does it willy-nilly. Like I was like, well, let's try it both ways. Well, the reality of it is I know better because I'm doing this for a long time. So that's why I was like, let me just double check my math. Let's figure the math out both ways and then figure out what comes out. So I would rather take, for example, even on a busy day, I'd rather take the additional 10 minutes and actually do the math in like an Excel spreadsheet or what have you, do the math to figure out what it is and be more specific. I'm always going to be more specific to the point where I am a match on the specific prefix in a prefix list, call that prefix from a prefix list from a route map and use that route map to do whatever you need to do. Be as specific as you can. Because I never want to be the, did I just screw something up? I never want to have that issue ever pop up. So, in situations like this, where there's a potential for address schemes to get skewed and stuff like that, always just take the extra few minutes and figure out your math before you go out there and try to do something and you accidentally screw it up. Because the key thing is here, like, okay, so do you use the most bits in common, or do you use how many subnets you have? The answer to the question is you always use how many subnets you have. And you try to figure out what the range is, and then if you can help it, you will always look for a summary range that encompasses everything you need to. But if you have, right here, this is what they consider contiguous. Contiguous means all in the same numeric range, right? 8 through 15, it counts 8 through 15. They're all contiguous. They all come in succession of each other. Discontiguous means that you've got like 8, 11, 13, 21, so on and so forth. Where if I was to do this as a single summary, I'd be saying that, let's say these 4 subnets, but I would be missing 9, 10, 12, and then 14 through 20. So that's 1, 2, 3, that's 10 /24s that would be encompassed in a very large summary that would never be reachable. You don't want to do that. So you would, in this case here, have to do potentially multiple summaries. Or you just let, 4 /24s go across the wire and you say the hell with summarization. So you take it on a case-by-case basis. Hopefully your addressing scheme isn't that screwed up and you can do that, but that's not always the case. I've worked with several customers where that has been the case, where their addressing scheme is so screwed up that either we re-IP address and stuff like that, or we say, it's not worth the extra hassle, or it's not worth the hassle of readdressing, so just let the large routing table let it be. So with that being said, ladies and gentlemen, that's what I wanted to discuss with you guys in this video. Hopefully that all made sense. So if you guys have any questions, comments, concerns, feedback, please drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.